Arteries, veins, and capillaries provide a highway for blood to travel throughout our body and allow all of our cells to get the nutrients and oxygen that they need. Hi, and today's lesson is on the different types of blood vessels. So there are three basic types of blood vessels. We have arteries, which carry blood away from the heart, capillaries, where the transfer of wastes, nutrients, and oxygens occur, and then we have veins, which return blood towards the heart. Arteries carry blood away from the heart, and the arterial walls are thick. They're typically lined with smooth muscle and then elastic connective tissue. And this allows them to stretch as the heart beats to carry that blood away. So we can see this. The artery has thicker muscular walls and a layer of smooth muscular walls, and then a smooth inner layer to allow blood flow to continue on through the heartbeats. Some conditions of arteries can include arteriosclerosis, which is where the artery walls become thickened and they lose elasticity. So typically this happens in older individuals because it's caused by an accumulation of fat deposits on the inside of the walls of the arteries, and this takes time. So this can lead to angina, which is chest pain, high blood pressure, and a stroke or a heart attack. An artery can also experience an aneurysm, which is a fluid-filled bulge on the inside lining of an arterial wall. And this weakened wall can cause an artery to burst or rupture, leading to a bleed. And this can occur in your brain, which would be very serious. When our arteries get smaller, they're going to be known as arterioles. And then from the arterioles, blood is going to flow into the smaller capillaries. Capillaries are blood vessels that allow for the exchange of matter between the body cells and the blood. So oxygen and nutrients go into the body cells, and wastes and carbon dioxide come out of the body cells. Capillaries are very thin-walled, and they only allow one red blood cell to travel through them at a time. And the thin wall, they're only one cell wall thick, and this allows for the diffusion of materials into and out of the blood, so like oxygen, carbon dioxide, and glucose. So in the capillaries is where we have all the, or they're embedded within all of our, in between all of our cells, so that our cells can, every single cell can receive oxygen and nutrients and get rid of their wastes. So capillaries are the smallest of blood vessels, and like I said, blood cells must pass through in single file. They're very tiny and they can be easily damaged. This is where we might see bruising occur when ruptured capillaries under the skin release blood into the spaces between the cells, called interstitial spaces. And these spaces are also filled with a fluid known as extracellular fluid, or ECF. So our cells are always bathed in this extracellular fluid. It typically doesn't contain blood. So venules will then receive the blood from the capillaries, and just like arterioles are small arteries, venules are small veins. Then those venules are going to join together to form larger veins. And veins are vessels that carry blood towards the heart. So within the pulmonary vein that's oxygenated carries blood back towards the heart. And veins are going to get progressively larger as they carry blood towards the heart until they all join up to the superior and inferior vena cava. Veins have an additional structure. They have one-way valves along their length. So this prevents backflow of the blood away from the heart. So because our veins are going to be fighting gravity from our legs up to our heart, we need to have those valves so blood doesn't pool in the veins on our ankles. So we can see that there's a valve at the top of that vein, and then the blood is actually pushed back to the heart through muscle contractions. So because blood pressure is low in a vein, it must be helped back to the heart. It's not under pressure from any heartbeats. So the muscles in our body are going to squeeze the veins and help the movement of blood flow back towards the heart. And that's why, again, the valves are necessary, because they prevent that blood from falling backwards. So if these valves fail or break down, gravity is going to cause the blood to pool towards the feet. And this can cause varicose veins, which is the bulging of surface veins. So here we can see how muscle contractions allow blood to flow back to the heart. So if we have contracted skeletal muscles, blood is forced upwards. And if we have relaxed skeletal muscles, blood is just going to kind of stay in that little vein component between the two valves. This is one of the reasons why they say it's important to get up and go for a walk around if you're on an airplane, because for sitting too long, You're not forcing blood up to your heart as quickly, and you could get some extra swelling um, in your lower extremities. And some people are at risk of blood clots because they're sitting so still for so long that the um, pooled blood in the veins starts to clot. So your blood pressure is the pressure of the blood on the walls of the arteries. And a surge of blood passes through the arteries with every single beat of the heart. So this is where we measure the pressure in the circulatory system. The walls of the artery, again, remember they're thickly muscled, are going to stretch and then recoil, pushing back on the blood and forcing it onwards away from the heart. And this is felt as a pulse when the arteries are close to the surface, like in your wrist or in your neck. When we want to measure blood pressure, we use a tool called a sphygmometer, and we can measure both our contracted heart blood pressure as well as our relaxed heart blood pressure. So this would be systole and diastole. So systolic blood pressure is the pressure on the vessel walls during a ventricular contraction. And this is going to be a higher number because our ventricles are contracting and forcing the blood out of the heart rapidly. Diastolic pressure is the pressure on the vessel walls during ventricular relaxation, so it's typically a lower number. And blood pressure is expressed as a ratio of systolic pressure, contracted pressure, over diastolic pressure, or the relaxed ventricle pressure. Typically, normal and healthy individuals should have a systolic pressure or a contraction pressure of less than 120 milligrams of mercury, so mmHg. Anything between 120 and 139 is considered pre-hypertensive, so it could lead into high blood pressure, and anything over 140 is considered high blood pressure. Normal diastolic or relaxed blood pressure should be less than 80. Between 80 and 90 is pre-hypertensive, and over 90 is hypertensive. So an average adult should have blood pressure 120 over 80 or less. So youth typically will have a lower blood pressure. And blood pressure is very individual dependent. Some people have higher blood pressure for them, and that's constantly what it is. And some people have lower blood pressure, and that's constantly what it is. But it's important to know the trends as well. If your blood pressure is constantly in the middle 120s over middle 80s, that's something that you might want to talk to your healthcare provider about. So when you're using a blood pressure cuff, you want to wrap it around your upper arm and increase the pressure until there's no blood flow going through that artery. So as the pressure slowly releases, so at this point 120, pressure of the heart contraction starts to push blood past the blood pressure cuff, and then blood flow is heard when the heart beats. So this is why they always put a stethoscope underneath, and then they have that in their ears so they can listen for when the sound of the blood begins in that artery. As pressure continues to decrease in the blood pressure cuff, blood is going to start to flow normally past the cuff and won't be heard anymore, even when the heart is relaxed. So at that point, we don't hear the flow of blood anymore. We don't hear it pumping past. And so that would be our diastole blood pressure. I hope you enjoyed today's lesson. Catch you next time.